Ba-dum-bum-bum-bum. Ba-dum-bum-bum-bum. We have a co-singer here today. Garrett, sing for us.
No.
Say ba-dum-bum-bum-bum. You want me to sing my opera?
Mm-hmm.
All right, we're here to teach you how to sing opera today. Are you ready? Whoa! Just kidding. I'm here to teach you today about tables and looking at the input and output of a table. I know you have seen tables before, but we're going to look at it a little bit differently today, okay? And I'm going to show you a different outlook on it. So here is the input, and here is the output column, okay? You could think of it like a gumball machine. If you put a quarter into the machine, okay, so here's where you put your 25 cents, and what do you get out? You get your gumball, okay? So the X is the value that you will be working with, either multiplying, adding, subtracting, or dividing, and the output is what you get, the result of it, okay? So we're going to look at this first one. This one is pretty simple. But what I want to first start out with is, previously, I've already seen it happen a couple times this year. Y'all are looking for a pattern this way and a pattern going down on the Y. And you're trying to notice the pattern that way. We are going to be focusing on finding the pattern between the X and the Y value. Okay, we want to find the relationship here instead of just the X and just the Y. We've got to relate them together. Okay, so let's look. We have 11 and we have 7. We're obviously, the number is decreasing. It is getting smaller. Okay, so we have two options. I can divide. That would make a number smaller. Or I could subtract. Okay, and so you just have to start looking at the problem and seeing, okay, what could I do here? 11 divided by what equals 7? Or can 7 evenly go into 11? No, it can't. If I did 7 times 1, that's 7, and 7 times 2 is 14. Okay, so that one wouldn't work. So division is is not a choice. So we are going to be subtracting, obviously. Now, what do we subtract 11? What do we subtract from 11 to get 7? Well, you subtract 4. So, okay. And then let's try it down here. You can't just assume the rule is correct on the first one. You've got to check with all X and Y's. So 10 minus 4 does equal 6. 9 minus 4 does equal 5. And then we're left with a question mark down here. We have to fill it in. 5 minus 4 equals what? 1. So our Y value down here equals 1. Okay? And we're also going to write a rule. And the rule for this one is you take whatever X is, okay, X, and we subtracted 4 from all of these X values right here, and we ended up with Y. You could also write it Y, my pad's being funny here, Y equals X minus 4. So you could write it either one of these ways. Okay, so we have found the relationship between X and Y, and we've also written the rule for it. So let's write rule right here. Okay, these are our two rules. Okay, and they're interchangeable. All right, so far so good. Let's look at the next one. It's doing the same thing. Okay, input and output. So this is again the X. The X is always the input. The Y is always the output. Okay, so we're going from 2 to 6, 3 to 9, 4 to 12, 7 to 21. And this is a perfect example of why you would not want to find the relationship between the X, because if you notice going down, it goes 2, 3, 4, and then jumps to 7. And I know on our last test that messed some of us up because we didn't realize that they had skipped numbers. Okay, and so over here is going to be doing the same thing. But if we find the relationship between X and Y and figure out what to do, we won't have to worry about them skipping numbers and trying to trick us. Okay, so let's see. We know we are going from a smaller number to a larger number, so I've got two options. I could either add or I could multiply, and I'm going to use the dot for multiply, not the X. Okay, let's see. What could my options be? I could try plus 4. Okay, 2 plus 4 equals 6. That's a true statement. But then you have to come down here and try 3 plus 4. Does 3 plus, whoa, that, you can barely read that. 3 plus 4 equal 9? No, it does not. Okay, and so 4 plus 4 does not equal 12. So you can rule that one out. That is not the correct relationship we're going to be using. Okay, let's try something else then. We've got multiplication we've got to try. 2 times blank equals 6. Well, 2 times 3, right? So let's try 2 times 3 equals 6. That's a true statement. What about 3 times 3 equals 9? Well, that's a true statement. What about 4 times 3 equals 12? That's a true statement. And let's see, 7 times 3 equals 21. That one's true. So the rule I'm going to apply down here to find the missing one is 9 times 3, and that gives you 27. So my missing value would be y, because it's under the y column, equals 27. Okay, and see there, I didn't have to worry about the missing, the skipping numbers here because I've noticed the pattern between x and y. I know I've said it 5 times, but it's very important. Okay, let's write our rule for this one. We're taking the x value, and what are we doing to the x value? What did we do with all these? Well, we multiplied it. Whoa, hold on. Let's see here. There we go. We multiplied it by 3, and we got our y value, which are the numbers in this column. And then you're right, you could switch it. Y equals x multiplied by 3. And really in algebra you'll see it where the y is on the left side most of the time, but there will also be the couple times where you'll see the y on the right. So you need to be able to recognize it either one of these ways right here. Okay? Alright, those two are easy. Now let's look at our tough one, our challenge problem. We're going to switch things up a bit. Okay, looks the same so far. We've got an x and a y. We've got an input and an output. Okay, this time let's look and try and notice our pattern. We have got 3 to 7, 4 to 9, 5 to 11. So I'm obviously increasing the numbers. So again, my two options to make the numbers bigger are to either add or to multiply. Okay, let's try. Let's try filling in. Let's try the addition. So 3 plus blank equals 7. We could fill that in with 4. Okay. That one's a true statement. All right, what about 4 plus 4? It does not equal 9. Okay, so that is already doesn't work. We can't do that. Okay, so addition is out. And then let's try, I'm going to write over in, let's see, a darker color. Let's try the dark green. Okay, let's try multiplication. 3 times blank equals 7. Nothing, because 3 times 1 is 3, 3 times 2 is 6, and 3 times 3 is 9. So I'm automatically out of both options. So you're thinking to yourself, what can I do here? Well, let's start to look at some different options. I'm going to rewrite the table down here since I've already written it. And it's nasty up there. 3, 4, 5, 6. Okay, 7, 9, 11, question mark. Okay, this one is called has a constant range. No, constant change of rate. Okay, so it's changing at the same rate. There's still a rule here, but it's going to take a little bit more to figure it out. All right, let's use the multiplication, and you're going to try and get as close to 7 as you can. Okay, so let's see. What gets us 3 times what gets us close to 7? Well, we've got 3 times 1 equals 3. We've got 3 times 2 equals 6. And we've got 3 times 3 equals 9. Okay, this is too little. That's too much. This is right where we need to be. Okay, so we know that 3 times 2 will give us 6. Okay, and then what would I have to do to get from that 6 to that 7? That's right, you just add one more. Okay, so let's try it down here. What if I do 4 times 2? I get 8. And then what if I added one more? I get 9. Okay, let's try down here. See if we have to check all of them. 5 times 2 is 10. Add one more and you get 11. Okay, so it's going to leave us down here. I'm going to move it over here. We're going to do 6 times 2. That's right. We're up here working on a Monday, Martin Luther King Day, while y'all are probably still sleeping in your cozy beds. You're welcome. All right. So we've got 6 times 2, and the rest of them, what we did was we added 1. So 6 times 2 is 12, and you add 1, you get 13. So our missing value would be 13. Okay, this is sort of a trial and error here. You're going to have to just try different options. You're going to have to try and get as close as you can to the y value, and then you fill it in with that missing link. The missing link was adding 1. Okay, so here's what this rule looks like. This is really algebra. Okay, so here's our rule. Sorry for being sloppy. All right. We took our x value, and what did we do to it? We multiplied it by 2, and then we added 1, and it equaled y. Now I'm going to show you the right way how to write it. Anytime you've got a variable next to a number and you are multiplying, you write the number first and then the variable. So it should say 2x plus 1 equals y. Or y equals 2 times x plus 1. Now notice I didn't have to put that multiplication sign in here, because any time that they're squished together like that, you should assume that you are going to multiply. Okay, if you don't understand this last one, please don't panic. We have a really good activity to show you how all this works, kind of make it click a little bit more, but I did want you to see an example before you come into class so that you could have an idea of what we're talking about. Okay, all right, that is all we have for you. Hope you have a good night. Hope you enjoyed my opera singing. Hopefully you don't learn from me. It was not very pretty. All right, see y'all later.